Greetings, my name is Daniel. Here I am to entertain you guys about paper chromatography of gel ink pens. So this is my group members. Here we have Suhaila, Suryahani, Daniel, which is me, Shafiq, and Afis.
Chromatography is the method of physically separating mixtures into individual components. It is a common laboratory technique used to identify unknown components in mixture. There are several types of chromatography. All types employ a mobile phase or element. It can be liquid or gas, which is forced through a stationary phase, a solid or semi-solid. Mixtures are separated because some components will be more attracted to the stationary phase and stick to it, while some components will be more attracted to mobile phase and travel with it. By eye, we cannot know if each ink color is a mixture or pure substance. Using chromatography, the component in a sample will migrate along the filter paper at different rates such that they become separate and separated from each other. The mobile phase takes advantage of different solubility or polarity of the components in order to separate them. This component traveling process is called elution. Chromatography can be used to separate ink, dyes, pigments in plant, or used to determine the chemical composition or many substances. Black inks can contain 3 or more colors. The number of colors depends on the manufacturer. Each ink formulation has a characteristic pattern that uniquely identifies it.
So let's go through the theory of paper chromatography of gel ink pens. In order to perform ink chromatography, you need to put a small dot of ink to be separated at one end of a strip of the filter. The end of the paper strip is placed in a solvent, and the solvent moves up the paper strip, and as it travels upwards, it dissolves the mixture of chemicals and pulls them up the paper. Then, the chemicals that dissolve best in this solvent will move up the paper strip further than chemicals that do not dissolve as well. So what is produced from this method is a chromatogram.
Next, for part C, interpretation of chromatography. First, wrote the name of the original ink color, each X mark. Each ink sample should no longer meet on the X mark and had traveled up the paper, become one or more separate color spots between the started and finish line. Circle around each color spot. Next, use a ruler and draw a plus sign in the center of each spot. Measure the distance from the started line to each spot sign. Record this distance for each spot on the lab report. This was the D value in cm. Measure the distance between the starting line and the finish line or faster up the solvent front reach. Record this distance. Then, this was the F value in cm. Calculate the retention factor RF for each part and record the value in the lab report. Next, for part C, interpretation of chromatography. First, wrote the name of the original ink color, each X mark. Each ink sample should no longer meet on the X mark and had traveled up the paper, become one or more separate color spots between the started and finish line. Circle around each color spot. Next, use a ruler and draw a plus sign in the center of each spot. Measure the distance from the started line to each spot sign. Record this distance for each spot on the lab report. This was the D value in cm. Measure the distance between the starting line and the finish line or faster up the solvent front reach. Record this distance. Then, this was the F value in cm. Calculate the retention factor RF for each part and record the value in the lab report.
Hello, Assalamualaikum. My name is Hafiz Faris and my student ID is 2022871612, and today I'm going to share about the example of paper chromatography in gel ink pens. For example, in figure 1 shows a beaker containing mobile phase and a prepared paper stationary phase. A line drawn at the bottom edge of the paper is the starting line, and the starting line and ink dots must be above the level of the mobile phase. when the paper is placed inside the beaker. If the starting line is below the liquid level, the inks will wash out into the mobile phase rather than elute out the stationary phase. Another line is drawn about 10 cm above the bottom edge of the paper. This is the finish line. Its location was chosen for this experiment because when the eluting solution reaches the line, any inks that are mixtures should be clearly separated. As we can see, the results came out and the figure 2 shows a typical paper chromatogram. A component with a given solubility travels along with the mobile phase at one rate, regardless of what other components are present in the sample. If the red color part of purple ink travels at the same rate as pure red ink and both stop in the same place, the two should be the same red ink. The two red spots should have the same retention factor or RF. The RF value is the distance D traveled by the spot divided by the distance traveled by the eluting solution or solvent front F, or retention value equals to D divided by F.
In conclusion, paper chromatography effectively separates the various pigments in gel ink pens, allowing for clear identification of each component based on their distinct travel distance. The choice of solvent significantly influences the separation process, with polar solvent moving polar pigments further up the paper. Overall, paper chromatography is a simple yet powerful method for analyzing composition of gel ink pens.